Hello everyone, this is Aishwarya and welcome to Beauty with Coach. So guys, today we are going to discuss about a new topic called linked list. Okay, so linked list is a linear data structure where elements are not stored in contiguous memory. So elements are not stored in contiguous memory allocation. Okay, I hope you understood. See, linked list is somewhat similar to array. And if you are not much familiar with array, please go and watch my previous videos on array, of course, and after that come to this video, you will understand. Okay, so yes, array is linear, linked list is linear too. So this is something we can say similarity between array and linked list. Okay, but the problem with array was you must know the size of array, okay, before inserting elements. So yes, we must know the size, but here there is no fixed size because linked list is something we call dynamic. Okay, so yes, we have, let's say, 3 or 4 nodes, let's say, and now we want to insert one more. We can easily do that. How? We will discuss later. Okay, so yes, here there is no concept of indexing, we have concept of nodes here in linked list. Okay, so in linked list nodes are there, okay, and linked because each node is linked with other one. Okay, how? I will explain. Okay, but one more thing before moving forward. See, every node is going to have at least 2 parts, data part and link part. Why I said at least? Because it can have 3 parts too, 2 links and 1 data. Data will always be 1, that is fine in every node, but yes, it can have either 1 link or 2 links. Okay, it depends. How? If your linked list is single linked list, then it is going to have only 1 link. Okay, only 1 link. So yes, and if your linked list is doubly linked list or double circular linked list, then 2 lists will be there. Okay, so okay, we will see these things later. I think we should stick to single linked list first, because if we understand single linked list, then it will become very easy, very simple for us to understand doubly circular or double circular or anything. Okay, so stick to basic single linked list for this video. Okay, not this video, for like next 2-3 videos. Okay, so yes, stick to single linked list. So here we are going to have 2 parts in each node. First is going to be data part and second is going to be link part. Okay, and in link part we will have address of next node. Okay, so link is sometime also called as next. Okay, so yes, here we are going to have address of next node in the previous node. Okay, I hope you understood. Don't worry, I'll show you examples. After that you will definitely understand. Okay, so yes, this is the structure. Okay, so as I already said, link will contain address of next. So who is going to hold address of first node? I mean, first node is first, so it has no previous node, isn't it? So who is going to hold address of first node? For that purpose we have a special link part only. Okay, we have a special pointer. Okay, in this node we are not going to have data part, or it's not actually node, yes, it's a pointer. Okay, and that pointer is called head pointer or start pointer. Okay, so 2 famous names, either head or start, you can say whatever you want. Okay, so head pointer points to first node. Okay, but what about last node? I mean, it's last node, so whose address it's going to hold? It's going to hold null or nothing. Why? Because it's the last node, it is not supposed to point to any other node, isn't it? So I hope you understood, I mean theoretical concepts. But why do we need linked list when array was there? See, when it comes to insertion and deletion, we were having some problems in array, isn't it? That is shifting. If you are not familiar, go and watch, you will understand. So yeah, we had to shift elements for particular insertion or deletion. Okay, in both the cases, but here we don't need any shifting. Insertion and deletion is very simple, very easy when it comes to linked list. Okay, we are not going to discuss this today or in this video, we will discuss in next video. Okay, so don't worry. And one more thing, one more famous operation was there, that was searching. So searching is better when it comes to array and not linked list. Why? Because because in array we have a concept of indexes, isn't it? So we will check whether, let's say, x element is present at yth index or not. But since here there is no concept of index, you cannot directly go. You have to traverse through whole linked list to check whether your element is present at present or not in that particular linked list. So searching, so time complexity of searching when it comes to array is big O of 1, okay, or the constant time. But when it comes to linked list, it is big O of n. So yes, this is the problem. I mean, searching is a problem when it comes to linked list, but insertion, deletion, these are very easy, very efficient when it comes to linked list and not array. Okay, so don't worry, today we are not going to discuss about insertion or deletion. Today we will see traversing. Okay, what traversing mean? See, traversing means going through all the elements from start to end. Okay, from first node to last node we are going to traverse, or we are going to move through each and every node. Okay, this is called traversing. So don't worry, and let's get started with traversing. You will definitely understand. Okay, so let's get started with traversing. So guys, we have 3 nodes in our linked list. Okay, first, second and third. So first we should focus on data part. Okay, so data part of first node is A, data part of second node is B, and data part of third node is C. Okay, but yes, what is the address of first node? It is 10, address of second node is 20, and address of third node is 30. Okay, now move to link part of first node. So link part of first node is holding address of second node, isn't it? And link part of second node is holding address of third node, and link part of third node is holding null or nothing. Why? Okay, let me explain. See, in first node link part is nothing but address of second node. It means this is pointing to second node. Okay, and in second node link part is nothing but address of third node. It means it is pointing towards third node. And since third node is the last node, it is not supposed to point to anywhere, isn't it? So it is pointing to null. Null means nothing, so it is pointing towards nothing. Okay, so yes, this is why it is not holding any particular address. But who will hold address of first node? So address of first node will be held by head. Okay, that's why head is here. Okay, so head is holding address of first part. It means head will point to first node. So now our linked list is complete. But now we should focus on our task. What our task is? Our task is to traverse through all the elements of linked list. It means to move through all the element of linked list. Okay, and for that we need one more pointer. Okay, and we already know pointer points to variable of same data type. Okay, so what is the data type of this or these nodes? So data type of these nodes are nothing but node, isn't it? So what will be the data type of temp? This is going to be node only, isn't it? So data type of temp is node. Okay, so initially in first line temp is equals to head, isn't it? What does it mean? It means whatever be the value of head, that is going to be value of temp. So initially value of temp is going to be 10. What does it mean? It means temp is now pointing to first node. Okay, and then while loop, and while loop is saying the condition is while temp is not equals to null. It means this loop is going to iterate till temp reaches null. Okay, and then print temp of I or temp of data. Okay, so after this we are going to have A as our output. Okay, so A will be printed. Fine. What is next line? Next line is temp is equals to temp of link. Okay, so now temp is holding 10. What is the value of temp of link? It's nothing but 20, isn't it? Temp of link is 20. It means now the value of temp is going to be 20. It means now temp is pointing towards 20 or the second node, isn't it? Temp is pointing towards the node whose address is 20. So now it's pointing towards second node. Okay, and its address is 20. It means yes, address is 20. It means temp is equals to 20 and not null. Since 20 is not equals to null, what will happen? B is going to be printed. So yes, B is printed. Now what will happen? Temp is equals to temp of link. So what is temp of link? This is nothing but 30. Okay, so yes, now value of temp is going to be 30. It means it is going to point to the node whose address is 30. So this is going to this is going to point to third node or C. Okay, since C is not equals to null, 30 is not equals to null, it means C is going to be printed, and then temp is equals to temp of link. What is temp of link? This is null. Okay, so now value of temp become null. It means no more iteration will be there, and yes, we traversed through all the elements of our linked list, isn't it? What is our output? ABC. So 3 nodes were there, so ABC needed to be printed, and yes, we printed ABC. So I hope you understood what linked list is, and yes, comparison of linked list with array, isn't it? And along with these two important topics, we understood about linked list traversal. That is seriously very important topic. Okay, so we understood 3 important topics in single video. So I think we should stop here, otherwise video is going to be too long. So it's time to wrap this video. So I'm wrapping up this video on this note. So stay healthy, stay fit, love you all. This is Aishwarya signing off. Bye bye bye. Bye bye.